Look closely at any massive, live software ecosystem, and you will see a structure struggling to support its own weight. The Echo project faces exactly this problem. The objective is to transform a heavily dependent NeoForge Minecraft Modpack into a fully standalone native game platform. The standard engineering reflex is to build a completely new native loader from scratch in isolation, and then try to port everything over at once. In an active production environment, that massive rewrite halts all forward momentum. It stops developers from shipping new features, and when the switch is finally flipped, it introduces fatal integration bugs across the entire codebase. Platform migration cannot survive as a brute force rip-and-replace operation. It has to happen in place. The safest path to extracting a new native runtime is to build the language of the future platform directly inside the existing legacy engine. To map this out, the development team relies on a rigid 28-phase implementation roadmap. This transition timeline spans from Phase 0, the legacy state, to Phase 26, native extraction. The intervening 24 phases are dedicated entirely to establishing API contracts, schemas, and metadata before any runtime engine swap takes place. Defining the strict vocabulary of the future system before removing the old engine ensures that the software can continue to integrate and ship updates during the entire process. For this in-place migration to work, the development team must enforce strict discipline over how different parts of the code interact. This chart shows the 7-layer dependency model used to prevent code entanglement. The base layer 0 holds the absolute core foundations, and the peak at layer 7 holds the individual pack roots. The absolute rule is dependencies only point downward. The bottom 3 layers, 0 through 2, strictly expose pure interfaces, registries, and diagnostic tools. The upper layers, 5 through 7, consume those lower contracts to compose actual user interfaces and gameplay content. If a layer 6 content module attempts to hard-code logic from a layer 7 pack root, the build fails. Blocking these upward dependencies guarantees that the shared core systems never accidentally rely on specific isolated content features. The model also discourages direct module-to-module communication on the exact same layer, forcing integration through shared interfaces instead. By rule, the shared foundational code is mathematically barred from entangling with specific gameplay or user interface logic. Without this rigid vertical isolation, any attempt to extract those lower runtime layers later on would drag the entire top-heavy codebase down with it. Layer 2 is the exact point where the migration bridge is constructed. In Phase 1, the team builds Platform Core to define module roles, feature IDs, and capabilities without relying on any specific runtime environment. Phase 2 introduces AdapterCore. This diagram shows how AdapterCore acts as the traffic director between independent contracts and the legacy engine. Watch what happens when a legacy content module is updated. It immediately stops talking directly to the NeoForge runtime. Instead, the module routes its execution requests directly into the Echo platform adapter. The adapter takes that platform contract request and translates it down into the specific legacy descriptor. This creates an operational paradox. The code add-ons speak the exact language of the future platform, but the legacy engine still executes the commands underneath them. This routing pattern successfully isolates the game logic from the underlying engine, satisfying the core requirement of a risk-free platform migration. Decoupling the code is only half the problem. External platform tools face a similar integration challenge. Systems like launchers, diagnostic tools, and AI agents need to read and understand the ecosystem's rules without actually spinning up the runtime. Phase 6 solves this by introducing the Echo Unit metadata ontology. Every asset in the platform is standardized into a uniform, readable data block. This diagram shows a standard Echo Unit declaration block. It uses a clean 6-part structure to categorize an asset. Notice the precise fields governing execution boundaries: standalone mode, provided features, and consumed features. Because the metadata explicitly declares these features, individual add-ons can integrate through abstract contracts rather than relying on messy, hard-coded module requirements. The platform also maintains a specific field strictly for AI metadata. This data routes directly out to external autonomous tools, like the Codex and Cyberdex agents. Reading this metadata allows those AI agents to accurately reason about task contracts and execute strict, risk-labeled automation actions without breaking active developer builds. The Echo Unit ontology turns the massive add-on ecosystem into a perfectly mapped, machine-readable graph. External tools integrate seamlessly without needing a single hardcode dependency. All of this preparation converges at Phase 26, the milestone where the legacy engine is finally scheduled for full removal. Recall Phase 2. A content module routes through AdapterCore into the legacy NeoForge runtime. The extraction drops the legacy runtime completely. In its place, the new Echo native loader slots precisely into the empty space. AdapterCore seamlessly redirects contracts into the native adapter. There is zero downstream impact. Because of the strict dependency model, absolutely nothing above Layer 2 breaks or requires a rewrite. The production modules simply continue executing the exact same platform contracts they have been using since Phase 1. This execution strategy offers a precise lesson for any software architect facing an overwhelming mountain of legacy technical debt. Never treat a massive platform transition as a localized rewrite event that halts development momentum. Real, risk-free migration is achieved by gradually enforcing a shared contract language inside the old system over time. Do that, and the final engine swap becomes a simple mathematical triviality.